If you're watching this video, hopefully you've already seen my video on 45, 45, 90 right triangles, or at least you know how to work with 45, 45, 90 right triangles. The basic concept we've been working with is the idea of using angle measures to find side lengths of triangles. And in special cases, there's some patterns that can be done pretty easily by hand, actually in a lot of cases pretty easily in your head. So with 45, 45, 90 triangles, for example, we know that you can multiply the legs by radical 2 to get the length of the hypotenuse, or you can divide the hypotenuse length by radical 2 to get the length of the legs. Pretty basic pattern, okay? We're going to talk about a different type of relationship here. These are what are called 30, 60, 90 triangles. They're really, really common, okay? A 30, 60, 90 right triangle will have a 30-degree angle, a 60-degree angle, and a right angle. Okay? And if you think about relationships in sides of triangles, just like if we have two side lengths that are equal and we get two equal angle measures, like in the 45, 45, 90 triangles, in a 30, 60, 90 triangle, you will have a 30-degree angle, which is the smallest angle. It should be opposite the shortest side, okay, the short leg. A 60-degree angle is bigger. It will be opposite a longer leg, okay, so this side will be longer than this side. And then the hypotenuse is 90. It's going to be the longest side. The hypotenuse is going to be across from that 90-degree angle, all right? So there are some patterns here because there are three different angle measures and three different side lengths. There's a little bit more going on in the patterns. So let's take a look at how that would work. I always think about the fact that 30, 60, 90 triangles are really half of equilateral triangles. Remember, equilateral triangles have 60-degree angles. If you chop them in half, you're going to get a 30-degree angle and a 30-degree angle up at the top. And so I always kind of think back to that because one of the patterns comes directly out of the fact that a 30, 60, 90 triangle is half of an equilateral triangle. Okay, so let's start out with some basic sides here. Let's say that I had an equilateral triangle with side lengths of 2. Okay, so if this side was 2, if I drop an altitude in here to make a 30, 60, 90 triangle, that 2 gets broken up into 2 equal parts. We've got a 1 and a 1. Okay, the original triangle was equilateral, so this side is 2, and of course this side over here is 2 if I cared about that side. I'm just going to focus on this triangle right here. Okay, so what I have is a right triangle with a side length of 2 and a side length of 1. Now I'm going to draw that triangle separately. Okay, so here's that triangle. We've got a side length of 2, and we've got a side length of 1. There's my 60-degree angle. There's my 30-degree angle. Okay? I should be able to use the Pythagorean Theorem at this point to find the missing side. I'll call that x. So according to the Pythagorean Theorem, x squared plus 1 squared is going to be equal to 2 squared. Okay? So x squared plus 1 is going to be equal to 4. That means that x squared is going to be equal to 3, which means that x is the square root of 3. Okay? I'm going to write this side length as radical 3, which is the same thing as 1 radical 3. Okay? So I have a 30, 60, 90 triangle. I have side lengths of 1, 1 radical 3, and 2. Okay? We're probably not going to take much of a pattern away from that example. But let's try another one. All right? Let's do a second one here. So let's say I have a 30, 60, 90 triangle. Let's say that the side lengths are 2. Remember that there's another half of a triangle here. This is really half of an equilateral triangle. Okay? So let's say that the original equilateral triangle had side lengths. I said 2 before. Let's make them 4. Okay? So this side is 4. This whole thing is 4. This whole side is 4. That means that this piece right here is going to be 2. Okay, and we're trying to find the height of the triangle right there. Okay, so according to the Pythagorean Theorem, a leg squared plus the leg squared is going to be equal to the hypotenuse squared. Okay, we're going to get x squared plus 4 is equal to 16. X squared is going to be equal to 12. And the key here is when you simplify it down, the square root of 12 is going to be equal to 2 radical 3. Okay, so what we have here is we have side lengths of 2. This side is 4, which of course is twice that side length. And the hypotenuse there is going to end up being 2 radical 3. So notice what we've got. We've got 1, 2. We've got 1 and 1 radical 3. We've got 2 and 4, 2 and 2 radical 3. Those are our basic patterns. Okay? Let's try it with another one. I'm going to write these down from the first triangle. We've got a 1 radical 3, and a 2. That's our 60-degree angle down there. Okay, let's try another one. Let's try one with side lengths of 3. Okay, here's my 60-degree angle. Okay, remember that this whole thing is half of an equilateral triangle. So if this little piece here is 3, this whole length is 6, which means this length is going to be 6, that length is going to be 6. Okay, so once again, over and over and over, we're seeing a pattern which hopefully is pretty basic now. That short leg, the side opposite the 30-degree angle, is always going to be half the length of the hypotenuse. Okay, we saw it here, our 30 would be up here, this is half of 2, and now we're saying that 3 is half of 6. Okay, if I do the Pythagorean theorem here on that other side, we're going to get x squared plus 3 squared is equal to 6 squared. Okay, if you solve that, you can get x squared plus 9 is equal to 36. X squared is going to end up equaling 27. 27, when you take the square root, ends up being 3 radical 3. Okay, and hopefully we have enough now that we can see some kind of a pattern. Okay, I've got sides of 2 and 4, 1 and 2, 3 and 6. Okay, you're always doubling the short side to get the length of the hypotenuse. Notice the other pattern. 2, 2 radical 3. 1, 1 radical 3. 3, 3 radical 3. It's a very simple pattern. The short leg always gets doubled to give you the hypotenuse. The short leg always gets multiplied by radical 3 to give you the length of the long leg. That's what's happening here. Okay? If you look at a textbook, they're probably going to give you some kind of pattern like this. And this can be proved with variables. I probably should do it right now, but I'm not going to show that for the time being. This side is x. Remember, it's half of an equilateral triangle. We've got the whole equilateral triangle there. So this side is getting doubled to give you the hypotenuse. That side is 2x. This side is getting multiplied by radical 3 to give you that side. Okay? So the pattern for a 30, 60, 90 triangle is x, 2x, x radical 3. Those are your missing sides. Okay? This can be used really easily then. For example, say I've got a 30, 60, 90 triangle, and keep in mind, these can be turned all kinds of different ways. So you might need to turn your paper or change your diagram to kind of set up in a way that matches up with this pattern. Let's say this side is 10, okay? And you want to find the missing sides. The cool thing about this is you're not going to have to use the Pythagorean theorem. You can just use the patterns if you have angle measures. And be very careful. If you're not given angle measures, if you don't see these patterns, it's not going to be one of these triangles. So make sure you're only applying this in cases where you're actually given the angle measures. But anyway, here's the point. The short side is half the length of the hypotenuse. So half of 10 is 5. Okay? The pattern says you multiply the short side by radical 3 to get the length of the long leg. That side's going to be 5 radical 3. Okay? Can be very quick, can be very easy. All right? So if I start you off, maybe this side over here is 6 radical 3. You always want to get the short side. Okay? And the short side is always the one that's opposite the 30-degree angle. So something got multiplied by radical 3 to be 6 radical 3. So we can divide by radical 3. That gives you 6. So to go from a short side to a long side, multiply. To go from a long side back to a short side, divide. All right? So 6 divided by the square root of 3, 6 got multiplied by radical 3 to be 6 radical 3. Okay? The pattern says double that to get the hypotenuse. Okay? I always try to get that short side because the patterns are all based off that short side. So I'll take half of this to get that length. I'll divide by radical 3 to get back to here. Whatever I need to do, get that short side. Everything else will come from that. All right? So again, if they give me 7 here, double it to get 14, multiply it by radical 3 to get that side, everything's good to go. Now, you are going to run into some challenges. You are going to get some cases that are a little bit tougher that don't look like the pattern. This happened also with the 45, 45, 90 triangles. Okay? So here's the challenge. If they give you like 2 radical 5 here on the short side, you still double it to get this side. So you're going to take 2 times 2 radical 5, and that's going to simplify to be 4 radical 5. And it's going to look weird because you don't see a radical in the pattern, but the pattern just says you just double whatever the short side is, and that gives you the hypotenuse side. Okay? And the pattern says you multiply by radical 3 regardless of what you're given. So 2 radical 5 is going to get multiplied by the square root of 3. That's going to simplify to 2 radical 15. Okay? Doesn't look like the pattern, but it does follow the pattern. Right? So if I have, say they give you something like 4 radical 6 over here. Okay? That's my hypotenuse. Get back to your short side. You divide by 2 to get back to your short leg. So 4 radical 6 divided by 2. 2 goes into 4 twice. You get 2 radical 6. It's going to look weird because the pattern doesn't look like you're supposed to have a radical there. But as long as half of your hypotenuse gives you that side length, you're good to go. Okay? This is going to get multiplied by the square root of 3 to give you that other side. So you're going to get 2 radical 18. Be careful here, radical 18 breaks up into radical 9 times radical 2. Okay? 2 radical 18 is 2 times radical 9 times radical 2. That's 3. 2 times 3 is 6. You get a 6 radical 2 for that side. It doesn't have a radical 3 at all after you go through the process of simplifying. Okay? But it does follow the pattern. You double it to get this. If you multiply this by radical 3, you'll end up getting that side there. Okay? It just looks weird. But the process is always the same. You're always multiplying or dividing by the same values. Okay? The other case you're going to run into, maybe they give you your 30, 60, 90 triangle. Maybe they give you a length of 9 over here. Okay? Not 9 radical 3, just 9. Okay? Always think from your short side. Okay? What do I do to the short side to get the long leg? I multiply by radical 3. So to go from the long side back to the short side, I'm going to divide by radical 3. I'll divide 9 by radical 3. Okay? Remember, you want to rationalize your denominator. So if you've got 9 over radical 3, multiply the top and bottom by radical 3, you'll get 9 radical 3 over 3. 3 goes into 9 3 times. This will simplify down just to be 3 radical 3. Okay? The pattern says double the short side to get the long leg. If you double this, you'll get 6 radical 3. So be careful. Most of the time, you're going to see a radical 3 with this side. This side is going to be double that side. Okay? But it's possible that you could have any kind of radical showing up for any side. You can dilate a triangle to have any possible side lengths. So the key is, if I double this, do I get that? If I multiply this by the square root of 3, do I get that? Okay, and I think you can see here, if I double that, I get 6 radical 3. If I multiply 3 radical 3 times the square root of 3, that's going to give me 3 times 3 does really equal 9. Okay, the pattern does check out. Now, every once in a while, you'll get something that's super ugly. Okay, so for example, you might have a side like 5 over here. Okay, same thing though. If you multiply by radical 3 to get this side, you're going to divide by radical 3 to get this side. Okay, 5 over radical 3 would be an unsimplified answer for that side. To rationalize the denominator, get rid of that radical in the bottom, multiply both top and bottom by radical 3, you're going to get 5 radical 3 over 3. 3 doesn't go into 5. There's no GCF for 5 and 3. Leave it as 5 radical 3 over 3. Okay? You still double that side to get the other side. 5 radical 3 over 3 multiplied by 2. If you're doubling, 2 is 2 over 1. So the numerator is getting multiplied by 2. That'll give you 10 radical 3 divided by 3. 3 doesn't go into 10, just stays like it is. Okay? So you're going to get some answers that look kind of weird sometimes, but the process is always the same. Multiply the short side by 2 to get the hypotenuse. Multiply the short side by radical 3 to get the long leg. That's how you're going to find the different sides of your right triangle. Okay? And same thing working backwards. Divide by 2 to get from the hypotenuse back to the short leg. Divide by the square root of 3 to get from the long leg back to the short leg. You do that, the process is the same every time. It really just comes down to how you simplify your radicals. Hope that helps.